In problem 1, we got the word marmalade, and it contains 4 vowels and 5 consonants. Find the number of possible arrangements of its 9 letters. So arrangements, we're talking about permutations, and there are no restrictions for A and the order. So all we're going to do is the number of things we've got, in this case 9 factorial, and divide by the identical items 3 factorial and 2 factorial. Now, part B, it says the arrangement must begin with 4 vowels. So here we've got our 4 vowels, and then we've got the consonants, and all we've got to do is figure out how many ways the first vowels can happen. Well, that's 4 factorial over 3 factorial, and then the rest of the consonants, that's 5 factorial over 2 factorial, and then we've got 240. All right, let's go to the next one. In problem number 2, we've got 5 men and 4 children and 2 women, and they're asked to stand in a queue. That's a line. Find how many ways that can be done. The women must be separated. So we're going to do stars and bars. Now, we've got 5 men, 4 children, and 2 women, but we're really only talking about non-women and women. So the non-women, the bigger group, they're the bars. And we've got to figure out how many ways to arrange them. And that's going to be the number of bars, or in this case, 9 factorial. And then the stars, that's where the women can stand. Now, it doesn't mean they have to stand at all the places. That's just the possible places that they can stand. Now, we only have 2 women, so obviously they're not all going to fill those spaces. But we've got 10 spots to choose from, and we're going to put them in 2. So we can find the number of arrangements for that is 10p2. And now all we've got to do is do 9 factorial times 10p2. And we can find the answer to this question. The reason we're multiplying them is because they have to happen together. Anyway, we're going to get this large number here. Now, for part B, all the children must be separated. So it's a similar kind of thing. We've got non-children and children. So we've got 7 non-children, and then we've got 4 children. Well, you'll notice we're going to have 7 bars, and then there's going to be 8 stars. So we're going to do the same kind of thing. This is going to be 7 factorial, and then we're going to multiply that times 8p4. And then all we got to do is multiply those two, because they have to happen together, and we get the total number of ways. All right, let's take a look at the next one. In number 3, we've got to find the probability that a random selected arrangement of all the letters in the word palette begin and end with the same letter. So basically it helps if we kind of map this out. We've got 8 letters, and if we start with an L and we end with an L, we can forget about the L's. We've got 6 letters left over, and we've got 2 E's and 2 T's that are duplicates. So the number of ways we can arrange those 6 letters is going to be 6 factorial over 2 factorial times 2 factorial. The thing is, we can do the same thing with the E's, and then we can do the same thing with the T's, and it's not going to change this middle section. So we're going to take 6 factorial divided by 2 factorial times 2 factorial and multiply it by 3 and get 540 ways. The thing is, that's not what they asked us. They didn't ask us for the number of ways. They asked us for the probability of it happening. So now what we've got to do is 540 is what we're interested in. We've got to find the total number of ways it could be if there was no restrictions. Well, that's going to be 8 factorial over 2 factorial times 2 factorial times 2 factorial. And we're going to get a probability of 3 over 28. In number 4, we've got 8-digit phone numbers, and they begin with 79. Now, in part A, they tell us that they want to know how many different phone numbers we can have. And we evidently can reuse the numbers because they don't tell us we can't. There's 0 through 9. That's 10 possibilities. So for part A, the 7 and 9 are fixed, but the other numbers are flexible. That's 10 to the 6th power, or that's 1 million different ways that could happen. Now B, it says find the probability that a random selected number is issued by the network. It ends with a 9-7. Well, so if we put a 9-7 at the end, that's fixed and that's fixed. All we got to do is figure out these middle numbers. Well, that's 10 times 10 times 10 times 10, or 10 to the 4th. And if we're doing a probability, we're going to do with what we're interested in, which in this case is 10 to the 4th, and divide it by 10 to the 6th, and we get a probability of 0.01. Now, part 2, it says what's the probability that they read the same from right to left? Well, if these first two are fixed, then these last two are also going to be fixed because it has to be 7, 9 if I read them backwards and forwards to be the same. Now, when I pick this one, that fixes the other one because they have to match. Now, when I pick the fourth digit, that's going to make the other one fixed because it has to match. So really what happens is I'm only going to really mess around with these two. That's 10 and 10. 10 times 10 is 100, or 10 squared, over 10 to the sixth. That's going to give me 0.0001 is my probability. All right, let's look at the next one. In problem 5, we got 12 books on the shelf. I don't think this was assigned, but we're going to do it anyway. Anyway, we got 5 at 15 inches, and we've got 4 of them at 20 inches, and then we've got 3 of them at 25 inches. Now, what they want to do is they want to stack them so that the shorter one, there's never a shorter one to the right. So basically what that's going to mean is that it's going to have to go tall to short. And to kind of give you a visual, if it kind of goes like this, well, then if the books are kind of lined up tallest to shortest, well, then I'm always taller than the book to the right. Anyway, the tall books, I've got 3 of them, so that's going to be 3 factorial to arrange those. And then I've got 4 of the medium ones, that's 4 factorial to arrange those. And then the small ones, there's 5 of them. So it's 3 factorial times 4 factorial times 5 factorial, giving me 17,280 ways. Let's look to the next one. In 6, we've got 11 letters, the word remembrance, and they're all arranged in a line. So we're talking about permutations. It says find the number of arrangements if there's no restrictions. So we're going to put these together. I'm going to put the letters with the same, and I'm going to separate the vowels because I see we're going to mess around with that later. Anyway, we've got 11 factorial, and there are 2 R's, 2 M's, and 3 E's, and so we've got to divide by those. And that gives us this number of arrangements. Now, for part 2, it says find the number of arrangements which start and finish with the letter M. Well, there are only 2 M's, and so we can take them off the board. And all we've got to do now is figure out the number of arrangements for the numbers in the middle, or the letters in the middle. They aren't going to include the M's, but they still have R's. So we're going to divide by 3 factorial and 2 factorial. We had 11, but now we only have 9 because the M's are there. Switching the M's does not increase the number of arrangements, so we don't have to worry about doing that. And so that's going to be our answer for part 2. It's going to be 9 factorial over 3 factorial times 2 factorial. And then for 3, we're going to arrange them so they do not have all the 4 vowels next to each other. Now, this is not saying that they have to be apart. It just means that there's not a situation where all 4 are absolutely together. So it's possible that 3 of them are together, or 2 of them are together, but just not all 4. And that's not the same as saying they have to always be apart. So what we're going to do in this case is we're going to find the total number of ways they can be arranged, which we already have. That was in part 1. And then we're going to subtract the number of arrangements where the vowels are together. And see, then what's left over has to be any situations where they are not absolutely all 4 together. So the way they're together, if I count them, the vowels as one thing, that's going to give me 8 things. And then I've got 2 R's and 2 M's, so I've got to divide by those 2 2's factorial. And then I'm going to multiply by the way I arrange the vowels, which that's going to be 4 factorial divided by 3 factorial. And so then all I'm going to do is subtract 1,663,200 minus 40,320. And then we're going to end up with this number of ways where the vowels, all 4 vowels, are not together. All right, now I've got new information, and they say 4 letters from the word are chosen. So now we're switching gears, and you can forget about anything we've done before. Now we're talking about combinations because we're choosing them. And it says find the number of selections that can contain no M's or R's, and at least 2 E's. So if we get rid of the M's and R's, well, now all we've got to worry about are B and C, and then the 3 E's and the A. They want us to choose 4 letters. So what we can do is, there's a couple different ways to approach it. Method one is to set up at least 2 E's. Now what's happened is, I still need 2 more, and when I take the 2 E's that I've fixed off the table, I'm going to have the letters B and C, and then an E, and then an A. And so I'm going to have 1, 2, 3, 4, 5 letters to choose from, and I need to choose 2 of them. So now to find what I'm actually going to pick, I just need to know what 5 choose 2 is. That's going to equal 10. Now, the second method is to break it down a little further. If I've got 2 E's, well, now I don't do the E's because this first scenario is just using the 2 E's. So that means I've got 1, 2, 3, 4 letters, and I'm going to choose 2. And those are non-E's. And then I'm going to look at, well, what if I used all 3 E's? Well, so now I still have 4 non-E's left over, but I'm only going to choose 1. And if I do that, I'm going to find out that I get 6 plus 4, which again is still going to be 10. And either way works. So let's go on to the next one. In number 7, we've got to find how many ways 15 children can be divided into 3 groups. Now, divided, the selected, chosen, placed in a group. We're definitely not arranging them, and there's no talk about an order, so these are combinations. Now, if there's no restrictions, well, basically, all we've got to do is put them in their groups. My group 1, well, they're going to have 15 choices, and I'm going to pick 5, and then 10, and then pick 5, and then 5, and then pick 5. So now all I've got to do is multiply these together and find out that I've got 756 ways to do that. Now for part B, it says 2 of the children are brothers and they must be in the same group. So let's go ahead and place them in group 1. Brother 1 and brother 2. Now I've got 13 people left over and I still need 3 for the first group. And then I go back to the same thing I did before. I've got 10 choose 5 for the second group, and I've got 5 choose 5 for the third group. And all I've got to do now is multiply these. Again, they've given you a restriction in the combination. Now forget about those brothers and just deal with the other selections. So that gives us this number of ways for number 7B. All right, let's look to the next. In number 8, we've got an entertainer, and they've given a performance of basically 4 different parts. Now they know 3 songs, they know 5 jokes, and they know 2 juggling tricks, and they can play 1 tune. And they want us to find the different ways we can choose the 4 items. So first, we've got 11 items altogether, and the A says we want to make the choices with no restrictions. So I've got 11 items, and I'm choosing 4. That's 11 choose 4. That's 330 different ways that can happen. Now part B says, what if they decide not to sing any songs? So then I'm only going to worry about these, which is going to give me 8 possibilities, and I'm still choosing 4, which is 70 ways. Now in part C, it says I can't tell more than 2 jokes. So basically I've got a choice of taking 0 jokes, 1 joke, or 2 jokes. If I tell 0 jokes, then the non-jokes, there are 6 things left over, and I can pick 4 of them. If I tell 1 joke, I can pick 3 out of the 6, and if I tell 2, I can do 2 out of the 6. At any rate, I take these individual selections and then add them together, and I get 265. All right, I'm going to take a break here and post this, and then work on the next video.